it doesn't matter. It's still dividing by negative infinity. It's still going to be 0. So algebraically, substitute in, see what you get. Okay, another question we can ask on this graph. So this was looking at x going out to the infinities and seeing that they were getting closer and closer to the x-axis. Now we're going to look at the limit, so maybe I'd call that A. Look at the limit as x approaches 3. And because it's, we're going to have to talk about it from the right and from the left. So let's go 3 from the right. And then we'll talk about approaching 3 overall. So from the right, that means I'm going to come on higher, and then I'm going to come back to the 3 from the right. What y value am I approaching? Well, technically none, but what describes the behavior here? What's happening to my finger? Where's it going to end up at? It's going to end up in infinity. So we're going to say the limit is infinity. Now we'll look at the limit as x approaches 3 from the left of the same function. So if I approach 3 from the left, I'm down on this branch, I want to get closer and closer to 3, what happens to my finger? Where am I headed as I move in? I'm headed down to negative infinity. Because that's describing the behavior of the graph here. It's not a single y value, but it's telling me what's happening. So overall, what's the limit as x approaches 3? Well, because they're both going in opposite directions, this has no limit still. If they were both going up or both going down, I would say the infinity. So if they were both going up, I would say positive infinity is the limit. If they were both going down, I would say negative infinity, but because opposite ways, there's no limit at 3. But if they do both go in the same direction, then you use that infinity as your answer. So, how are we going to do that? That's looking at the graph and getting it. How can we do it algebraically? If at any time your problem takes on 1 divided by 0, you're going to say that's infinity. Instead of undefined. And technically we can break this into 2 parts. If it's 1 over 0 on the positive side, you're going to say positive infinity. If it's 1 over 0 on the negative side, you're going to say negative infinity. And I'll talk about that in a minute here. So we will look at the 2 that we just did algebraically instead of looking at the graph. So the limit as x approaches 3 from the right, and I'm going to take the time to write the function down here because it's at the top of my page so we can see it. Okay, I'm putting in a 3. 3 minus 3 is going to give me 0. But I'm technically putting in numbers a little bit bigger than 3 because it's 3 from the right. I'm talking 3.00001, 3.0000001. So when I put in numbers just slightly bigger than 3, these are going to get close to 0, but still on the positive side. So this x value, all of them are slightly bigger than the 3. So that tells me infinity. Just what I had back here. Now, if we look at the limit as x approaches 3 from the left of that same function, again, if I put in 3 minus 3, I get 0, but I'm putting in numbers just slightly smaller than 3, 2.999999. And if I'm taking 2.99999 and subtracting 3, I'm getting slightly negative numbers, close to 0. So when I divide by that negative 0, I'm going to get negative infinity. Oh, math, who knew it could go there? Okay. Alright, so the first part of your assignment is going to have you sketch some graphs with some conditions, just like we did in the last section. So let's take a look and see how you do. Sketch a graph. Let's go. Your graph has to show that the limit as x approaches 5 from the left is infinity, and the limit as x approaches 5 from the right is negative infinity. Oh, is infinity. I lied. Both of them are infinity. Both positive infinity. Pretend that's not even there. Alright. So, it says x approaches 5, so we need to get out to 5. So as I approach from the left and the right, I got to be headed up to infinity. So the only way for that to happen is to have that vertical asymptote there. So, does this say anywhere put in a vertical asymptote? Nope, you've got to be able to figure that out. If I'm going up to infinity, I'm not stopping at a y value, I've got to have that asymptote there. So we put our two little branches in here, and we're good. Try another. Sketch graph that shows the limit as x approaches infinity is negative 2, and the limit as x approaches negative infinity is 3. I prefer that you stop the video right now and try to get this one on your own. Think about it for a minute before you just watch me do it, because it helps to kind of think through these and see what you could do with this on your own. So do yourself a favor, stop, give it a minute of thought, see what you come up with, then hit play again. So I'm going to continue on. Hopefully you try my suggestions. So this says as x goes out to infinity, I want the limit to be negative 2. So if I think about it, negative 2 is down here. As I go out this way, I want to be approaching this negative 2. And as I go out to the left, I want to be up at 3. So what I'm going to do is put in a horizontal asymptote at negative 2. And then 1 at 3. So as I approach out to infinity, I want to approach the negative 2. And then as I go this way, there is more than one way to do this one. I was hoping maybe you'd come up with something else on your own, but that's okay if you didn't. I'm going to start a new page for this next example, just in case. F of x equals 1 plus 1 over 3 minus x Okay, first thing we're going to do is sketch it, and then we're going to find some limits and a delta. So, let's sketch first. Obviously, we're going to have something happening at 3, because that's going to make this denominator 0. Plus 1 divided by, in parentheses, so I missed the parentheses, 3 minus x. Okay, there's our vertical asymptote happening at 3. Looks like I've got a horizontal asymptote somewhere here, but I can definitely see this is crossing the x-axis. I'm going to get rid of some of that y just to make sure I know what's going on there. So the window, I'm going to get rid of some of that negative 3 to... Yeah, I can definitely see there's something happening on the horizontal there. Definitely see something happening across here, but I'm not exactly sure where because I didn't look at the table. Alright, first question. Can you tell me the limit as x approaches 3 from the right? Let's get it from the graph, and then we will get it algebraically. So approaching 3 from the right, I can definitely see them going off to negative infinity. Algebraically, how would I have gotten that? I'm going to plug in the 3 in here. I would get 1 plus 1 over 3 minus values of 3 from the right. 1 plus 1 over, yes, you'd get 0, but would I get positive, a little bit positive of 0, or a little bit negative of 0? 3 minus numbers a little bit bigger than 3 would make this negative. And anything 1 over 0 is a form of infinity. Because this is negative, it's negative infinity. So adding 1 grain of sand back to no sand on the beach, still negative infinity. Try another. The limit as x approaches 3 from the left. So let's get it from the graph, then we'll do it algebraically. So approach 3 from the left. You see my finger is going to climb up to infinity. Algebraically, I'm just going to put in values of 3 from the left into the x. So I got 1 plus 1 over 3 minus values of 3 from the left. Zeros, are they going to be positive or negative? Am I going to stay on the positive side of 0 or the negative side? These are smaller than 3, so it's going to be positive. So 1 plus infinity. Infinity plus 1, still going to be infinity, just like we got from the graph. So what's the limit as x just approaches 3? Well, you can see as I approach 3, there's no pattern to describe because one's going up, one's going down. They definitely don't come together. None. What is the limit as x approaches positive infinity?